Atmospheric pressure can cause a window to shatter with a force equivalent to 1,000 pounds per square inch. When sunlight passes through a window, it's refracted or bent due to the varying densities of air molecules. This bending effect is known as dispersion, and it's responsible for the colorful spectrum we see in a rainbow. But what happens when the sun's rays hit a window at an angle? The light is refracted again, and this time, it's focused onto a single point. Imagine a magnifying glass, where the sun's rays are concentrated onto a tiny spot, creating a scorching hot temperature. But that's not the strangest part. The focused light can also cause a window to shatter with a force equivalent to 1,000 pounds per square inch. To understand why this happens, let's take a closer look at the structure of a window. A typical window is made up of two panes of glass, separated by a thin layer of air or gas. The glass panes are held together by a frame, usually made of metal or wood, which provides additional support. Now, when the sun's rays hit the window at an angle, they create a region of high pressure on one side of the glass. As the pressure builds, the glass begins to deform, and eventually it shatters, releasing the built-up energy. Wait until you hear what comes next. The sound of shattering glass can reach levels of up to 140 decibels. For comparison, a rock concert can reach levels of up to 120 decibels, and prolonged exposure to such loud noises can cause permanent hearing damage. But that's not all. The shockwave created by the shattering glass can also cause nearby objects to vibrate violently. Scientists have recorded instances where the shockwave from a shattered window has caused nearby objects to vibrate at frequencies of up to 100 Hz. To put that into perspective, a typical guitar string vibrates at a frequency of around 100 Hz. Now you might be wondering, what happens when the glass shatters and the pressure is released? As the glass breaks, the air molecules inside the window's frame are suddenly released, creating a pressure wave that radiates outward. This pressure wave can cause nearby objects to vibrate, and in extreme cases, it can even create a mini explosion. But that's not the strangest part. The pressure wave can also create a series of tiny shock waves that can travel through solid objects. To understand why this happens, let's take a look at the physics behind shock waves. A shock wave is essentially a series of pressure waves that travel through a medium, such as air or water. When a shock wave encounters a solid object, it can cause the object to vibrate violently, creating a series of tiny shock waves. Imagine a series of dominoes falling, where each domino represents a tiny shock wave. As the shock waves travel through the solid object, they can cause damage to the object's internal structure. But what about the impact on the surrounding environment? The shock wave can also cause nearby objects to vibrate, and in extreme cases, it can even create a mini explosion. The sound of shattering glass can reach levels of up to 140 decibels, causing damage to nearby objects and potentially causing permanent hearing damage. In extreme cases, the shockwave can even cause nearby objects to shatter, creating a chain reaction of damage. To mitigate the effects of shattering glass, scientists have developed specialized materials that can absorb the shockwave and prevent the glass from shattering. One such material is a type of flexible glass that can absorb the shockwave and prevent the glass from shattering. Imagine a type of glass that can absorb the shockwave, much like a rubber band can stretch, and then return to its original shape. This type of glass is made by infusing the glass with tiny particles that can absorb the shockwave and prevent the glass from shattering. But what about the impact on the environment? The sound of shattering glass can cause damage to nearby objects and potentially cause permanent hearing damage. In extreme cases, the shockwave can even cause nearby objects to shatter, creating a chain reaction of damage. To mitigate the effects of shattering glass, scientists have developed specialized materials that can absorb the shockwave and prevent the glass from shattering. One such material is a type of flexible glass that can absorb the shockwave and prevent the glass from shattering. Want more mind-blowing facts about atmospheric science and weather phenomena? Subscribe for more incredible stories like this. If you found this fascinating, subscribe for more incredible stories about the natural world.